Okay, so good afternoon, everyone who joined from the Europe and Eurasia region, or maybe some part of Latin America, and good morning to participants from North America. I believe that we have quite a diverse audience today, as I saw participants registered from across the globe, from all regions, which we are very happy about. As you know, this webinar is part of the EU Spring Phenology campaign that is organized by our team, the Europe and Eurasia Regional Coordination Office. My name is Cheryl Barkas, and I'm here today with my colleague, Lenka Kleger. She will be providing support for you in case you need any technical help with microphone, camera, or anything. Just please write to her in the chat and she will help you out anytime. And also, as Lenka mentioned, you can use the chat to post your questions anytime during the webinar, and we will get to them later on. We will spend together about an hour, and we'll be talking about the importance of phenology for the Earth system science, and also the importance of your work, the importance of submitting data to the GLOBE database, because this data is very precious to us and to the scientists who use it for their work, as you will find out later on in which ways. And with this short introduction, I would like to welcome our expert speakers today who joined us from Alaska. Today we have here Christi Buffington from University of Alaska Fairbanks, and she's also a member of the GLOBE Implementation Office. Then we have here Joyanne Hamilton, who is a long-time GLOBE teacher. I believe she is with GLOBE almost from the very beginning, and she's joining us from the Shageluk, Alaska. She's a teacher at Innoko River School. And our third speaker is Cheryl Williams, who's been also with GLOBE for a very long time. She's a teacher at Palmer High School at Palmer, Alaska. And she's also the current US Northwest Region GLOBE Partner Coordinator. So welcome to all of you. Thank you very much for accepting our invitation today and for waking up so early, as there is 8 a.m. At your time zone. So we really appreciate that you joined today. And with this, I would like to give the floor to Christi to start with her presentation.
Wonderful. Thank you so much for welcoming us this beautiful morning here. Joy Hamilton, you see the sun coming in Shageluk behind you. So there it's evening, afternoon where you are. So thank you. And we're bringing some sunshine in with us here in our morning in Alaska. Our time, all three of us, Joy, Cheryl, and I, are all part of the NASA funded project, Arctic and Earth STEM Integrating GLOBE and NASA. And that's the hat that I'm on, that I'm wearing today, is that I'm a member of the Arctic and Earth Science team. And we're presenting today why phenology matters. And we all have something in common. And we have been doing green up and green down with birch trees. So here we see a picture. This is the forest by my house. This is my dog, Dizzy. And these are our Alaskan birch trees. And we'll be learning more about them today. So thanks again for inviting us. I know that you are asking us to really talk about the importance of phenology and understanding Earth system science and importance of working with GLOBE data. So we hope we cover those from not only collecting the data, seeing data from space and remote sensing, but also working with entering and getting students out in the field to enter data and submit observations. So I looked at some of your other beautiful webinars that you've had so far. You have amazing scientists as well who you've defined phenology. I'll just refresh that definition a little bit here. When I think of phenology, I'm thinking of three main categories. I'm thinking of really the timing of cyclical events that happen over and over and over throughout, the seasons and in these cyclical events in nature. There are certain patterns and life cycles that we can observe in those cyclical events. And the timing is very important across human history as we study from generation to generation the timing of these events. It's also a field of ecological research, as you know, Lenka, I was reading your paper last night on phenology, and it's how living organisms are responding to cues. And that could be day length, temperature, rainfall, migration patterns. We're not just looking at plants, we're also looking at animals, pollinators. And it's also a way of life. So it's knowledge passed on through generations, and Joy Hamilton will be focusing really on that aspect of phenology with Indigenous cultures in Shageluk, Alaska. So we are sharing 3 stories today on why phenology matters to scientists, but also to us. I'll be sharing more of the data and the science, looking at birch. Joy will be focusing mostly on culture and community and all those years of having her students get outside and do globe data collection. And Cheryl Williams will be sharing curriculum and strategies that teachers can have, as well as what opportunities that Globe has provided to students in getting outside and collecting data. We come from different places, just as all of you who are on this webinar, you speak many languages across Europe and Eurasia. Same as in Alaska. Alaska is a huge, huge place. And look at all the different, over 20 language groups, different Alaska Native language groups across Alaska. The 3 of us are on different lands, ancestral lands with different languages. I'm coming to you from the Trothyeta campus of the University of Alaska Fairbanks. And I colored this orange here because it's on lower Tanana Dene land. And the Dene language is common with all of these places where we're coming from, but they are different language groups. Dagan Hatan, Dene land in Shageluk in this area. And then we have the Matanuska-Susitna Valley where Cheryl is. And that's, let's see, in this area. And that is Denina and Atna Dene land. And we thank the Dene people for their ancestral knowledge, the observing of the seasons throughout time and sharing that knowledge through generations, and the stewardship of these lands where I'm very grateful to be a guest. So when, I mentioned at the beginning that all 3 of us are part of the Project Arctic and Earth STEM Integrating Globe and NASA, and we see that Dr. Elena Sparrow has joined, and she's the principal investigator of this project and long-term. Many of you know her in Globe. And so thanks for coming, Elena, and thank you for this beautiful project, Arctic and Earth Signs. One of the ways that we start in this project is really learning from people about changes that they've seen. So it's kind of starts in the seasonal thinking of phenology. Learning about the signs and the impacts that communities have faced by listening to elders and long-term knowledge holders. And then the next step is really thinking about what youth already know. What have they already observed? And that's what I'm going to be focusing on in the next few minutes. in this Arctic and Earth Science project, then we tap into the knowledge that students already have, teachers already have, and then link it up to what they learned from listening to elders and long-term knowledge holders about what changes they've been seeing. And then they start doing the exploration, the globe investigations, collaborating with scientists, making sense of the data, and then they give back to their community through stewardship. And I've looked at some of what the European Phenology campaign has done, and you are also giving back to your communities as well. So let's focus today on paper birch. I mentioned before, this is actually more related to, it's Alaska paper birch, or Betula neoalaskana. It is a species of birch trees that belong to the circumpolar complex of birch. It's more closely related to the Asian species of birch than are in the lower 48 of the United States. And it's also called resin birch because these seedlings and branches have these bitter tasting resin dots on them that the moose will not like to browse. And so it protects some of the branches. And I just want to show, so that you can see this beautiful land that we are on. I found this video of Green Up in Fairbanks, Alaska in 2019. This was made by the Geophysical Institute, and you can see these satellites. People on the ground are collecting data, but meanwhile, satellites are orbiting in University of Alaska. We're receiving that data at the Alaska Satellite Facility while observing from the ground as well, which is kind of why GLOBE was started in the first place, to link up ground-based and satellite observations. So April 30th of 2019. Now we have May 7th. May 14th, boom, those leaves are measurable now. And May 21, those leaves have definitely burst in their measurable size. And that is the Green Up. 4 weeks of Green Up seen in a time lapse. So that's one way for students to study Green Up, is from looking at different scales. They're going to be looking at individual leaves, 4 individual leaves. They're also looking at what they can observe from a camera. That's where Globe Observer Land Cover is such a great tool. And then they are also looking at satellite data. And what kind of satellite remote sensing data are we talking about? One of the aspects that I wanted to share with you that's very accessible for educators and for students is to look at the leaf area index. I have a ginormous link here, and if someone could put it in the chat, that would be amazing. These are the Green Up protocols that are published in My NASA Data. And in that, there is also a wonderful way to look at leaf area index, which is the amount of leaves relative to the amount of land area that those leaves are occupying. And I'll show you this My NASA Data visualization in a story here in a minute. So as I was thinking about seeing how to teach students, I was thinking I've been a teacher and I want to connect with what students already know. I started going back to things that I remember in spring. In 2022, I got a puppy. This is Dizzy here. And I remember getting outside doing a lot of Green Up observations because this little puppy needed to walk. So she loved climbing up these giant snow piles. It was a very, very wet, snowy winter in 2022. And then, wow, just from April 27th to May 10th, look at most of the snow has melted. You don't see those big piles. Maybe some fresh snow had fallen. You can see our tracks. These are the kind of things that a lot of young students or young learners will be able to relate to is, you know, when they got a puppy, getting outside, noticing the tracks. Then all of a sudden, what happened between May 10th and May 22nd? There's this mystery. I don't know when green up actually happened because I was so busy with this puppy and dealing with all the meltwater from all the snow that boom, now we have all these trees. These are birch trees here. This is another species of flowering shrub in the foreground. Here's our globe flag in my neighborhood because we were doing soil samples in the neighborhood. But here you can help me. Globe students can help with this mystery of looking back to what I remember, a big snow year, getting the puppy. When did green up actually happen? Well, the spring mystery, let's see, we need more data, more facts to solve this puzzle of when it happened in 2022, 3 years ago. I remember, okay, we live on a south-facing slope. That's important because green up's going to be a little bit earlier with more sunlight. I remember with Dr. Sparrow, we led a booth outside to teach people how to measure their leaves and, you know, the size of the buds as they were swelling and the size of the leaves as they burst. So I had collected these and I remembered that the leaves were really measurable on May 14th. I decided to start doing some gardening on May 21st, and I did that because that's when the ground had thawed. So that's all I have. Going back to my old pictures, I don't remember when green up actually happened, but it's going to be sometime, you know, when we could see it from space between leaf out and when the ground thawed using that leaf area index that I mentioned from NASA. So students can use GLOBE to answer this question. Scientists also use GLOBE to answer when these phenological events happen. So what I did is I went into the GLOBE visualization system. I clicked on green up and I simply put in those clues. I wanted to look for data in the area where I live between May 7th and May 28th. And I found some sites in my neighborhood. This one is at Pearl Creek Elementary School. This one's at the University of Alaska Fairbanks. So I remembered that in order to collect these branches, Elena and I had gone outside and actually recorded the day at the Trothyetta campus, Trothyetta lawn here, of bud burst. So puzzle solved, we actually got GLOBE data on May 13th, right when the buds were bursting. And you could see that we did only one measurement, or I did only one measurement. That's why this data, because we only have one measurement, the leaf states have the first occurrences of bud burst, dormant, and the length measurable all on one date. There's only one greening cycle because there was only one observations. And we did that on I did that on 4 plants. So even though I only went out one time, it was still a useful observation that then verified my puzzle of when did bud burst happen. I haven't yet answered when green up has happened. But you can see that I'm missing a time series. Like I learned through this, making this presentation, that it's so important to go and get repeated observations to actually measure the length of the leaves. Not only just one time. One time is helpful, but please, scientists, myself included, need repeated observations. So I learned from my own one-time observation. And we can also get data from satellite instruments. So I work at the Geographic Information Network of Alaska, and there happened to be a very snowy year recorded from satellite data it was declared that green up in Fairbanks was on May 17th, not the same day, May 13th, as bud burst. And why is that? Because those leaves had to swell enough so that they took up more land area. That leaf area index is important. So here we are in Fairbanks. You can see from satellite instruments that the VIIRS data, and this is a red, green, and blue image, and you can see a lot of green in here. But what are all these other colors? The dark blue that we see here, that is old or very wet snow. The light blue that we see here is new or dry snow. And then when there's high clouds, this is why it's also important to get cloud observations using GLOBE, is that high cirrus clouds that are composed of ice are shown in this beautiful cyan color. You can see these cirrus clouds here. And then the water-based clouds are more white. So a lot can be found from making a composite image from the wavelengths of light that is reflected from clouds and from plants. And I just wanted to share two more tools with you before I give some time for questions, and that is using the leaf area index. So this is a tool that all of us can access from My NASA Data under the Green Up protocol. This uses Earth Engine apps. And what I did here is I wanted to see the comparison of April, when there was so much snow and my puppy was on this big piles of snow, to May. And what I selected, and this is the units for the leaf area index. It's a unit-less, a dimension-less unit. So there's a scale from 0 to 7, with 7 being more leaves that occupy. So values greater than 1 means that the location's covered with several layers of leaves, as in a forest canopy. And you can see that this index is very pale green in May of 2022. So this is a screenshot, but there's a slider that I compare the 2 months. And then I started wondering why, like you could use my little lesson plan in exploration to make this presentation was really inspired by a lesson plan and activity from GLOBE called the Alaska Spring Mystery, a GLOBE data exploration using data from Innoko River School in Joy Hamilton and Shageluk. And it's really looking at the timing when the buds first open and expose those leaves within. Genetics, the latitude, I mentioned south-facing slope aspect is also important. The temperature and the moisture is really what are the 4 factors that were affecting bud burst. And then as the trees grow, as the leaves grow, that's the accumulated temperature over time. So here, this lesson plan comes from where Joy is in Shageluk. And I also wanted to, I'll fast forward here, to show that I started getting curious about, well, wait a second, we know that it's getting greener. Satellite imagery has shown that it's getting greener across our Earth as our temperatures have increased. So I thought maybe it would be really fun to use this My NASA data and explore, is it being greener 20 years ago compared to now? And I plugged in May of 2002 and compared it to May of 2022. And then I found the slider and actually found the opposite was true. Something was different in May of 2002. It was actually an earlier green up at that time, which led me to be curious about what was happening 20 years ago. That's another great exploration you can do with students when they think about life cycles and starting to think longer term than just one season. And then I started getting really curious about the Czech Republic. and what was going on from 2002 to May of 2022. And there, 20 years ago, this area was a lot more green than 3 years ago. So I would love to play around with this, ask you questions. What is happening in this area that it was so much more green, faster 20 years ago than today? So I wanted to stop there. It's just a very quick overview of how you can access some satellite data to compare at different scales to what students are learning and observing. But I wanted to leave it open for any questions before we move on to Joy in Shageluk and at Innoko River School.
Thank you, Christi, for sharing these tools with us and the lesson plan and this beautiful example of combining satellites and data from the ground. So I would like to ask all of you to please ask questions either in the chat, or you can just unmute yourselves and ask directly, Christi. I'm checking the chat, but I see many greetings, but no questions yet.
I have one question. First of all, welcome from Georgia, Tbilisi. I have one question, dear Christi. It was very amazing to see this video that these coniferous trees are blossom every week, every month, and maybe some very fun question. But how did you shoot this video? You had some camera, or it was from satellite videos? What? How can you made this video?
Oh, thank you. Yes, at the Geophysical Institute on the top of the building is a webcam. So it's a
like
camera
24 hours. Yes, it's
that runs 24 hours. And I actually check that video all the time because I don't have a window in my current office. So I want to know what's happening and I look at the video. So if any of you are interested in what it looks like in Fairbanks, Alaska, I'll find that link and put it in the chat. And you can also, there's videos of the aurora as well from anywhere in the world you could be looking at. Thank you, Marina.
Amazing, great job, thank you. We have such kind of opportunity. Great, thank you.
Thank you so much. Well, with that, I think we'll turn it to Joy Hamilton. Oh, okay. Joy, are you able to unmute? The unmute button typically lives, let's see, where is it?
In the left bottom corner, there should be an unmute button. Like very left and down.
But you also can unmute all participants.
I asked Joy to unmute, but I'm not sure if she got the prompt. I was pushing a button, but Joy, can you hear us? You can hear us, but we cannot hear you. Feel free to.
I think, yeah, and it's possible, Joy, as you look for that button, sometimes they get so hidden in our Zoom session settings. And if the host can manually go in unmute Joy, that's possible as well. And if you wanted to make me a host, I might be able to try to help. However, if not, we can go to Cheryl and then come back to you, Joy. Would that work?
Well, Christi, you're a co-host now, so you have
okay.
I cannot really unmute someone. I don't know how, but if you can, that would be.
I'll work on it, and I will, I think the best thing might be to do, okay. Joy
I
is
think she's
rejoining.
rejoining. Yeah, rejoining.
Sometimes it just gets somehow frozen.
But while Joy is, oh, say again. Yes, we can hear you, Joy. Thank you.
I had freeze up on my Zoom. I don't know, maybe too many tabs open. You know how it gets when you're a teacher. Yes, hello. I don't have control over the slides, right? All right, I'll just give you a thumbs up every time. Thank you so much, Christy. So one of the things that I wanted to share with you is this picture to honor my husband's family. And the picture on the left was taken by a missionary, an Episcopal missionary back in the late 1800s. And he took that picture of my husband's grandmother. And that is a picture of her probably around age 12 or 13. And then there's a picture of her holding our daughter at age 103. And we honor our ancestors, you know, who taught their children so much about reading the land and honoring the cycles of growth and regeneration and honoring the seasonal times of preparation for hard winters and knowing that during winter dormancy, life again will come. Even during the hardest of winters, there is laughter and beauty and great gatherings of thankfulness for the harvests of fish, moose, caribou, plants, and berries. People will tell you that when the willow branches start turning orange in late February and early March, that's not green up yet. But when the willow branches themselves start having this yellowish, orangish tinge to the branches, the sun is getting higher in the sky. There's more sunlight getting to those cells, you know, in the trees. And when the sun's rays start, they're seeking out the dark hidden places of winter. And that means the sap has started flowing slowly to the branches. And then the buds start forming. Thank you, Christy. So as Christy mentioned, timing is everything. On the left, you see a picture there of our fish fence after freeze up. Freeze up has been occurring later in our area of Alaska. This normally, and I shouldn't even use the word normally anymore, because what's normal? You know, normal is not normal anymore. And so what has happened in the past is normally in October, my husband's tribe builds something called a fish fence. And usually it extends all the way across the river. But because the river has been freezing later in the year, the fish fence is built later. There's one big large run of whitefish that comes up the river or down the river during freeze up. And, you know, the men, the elder men are usually the ones that start the fish fence, and the younger guys go out there. But it's probably only about 4 millimeters thick when people start going across, because that last fish run of the year, the last subsistence fish run of the year, is so important. It's vital to it's vital to all life on land there is getting that fish. And then you can see a green not a green dun, that's a spring thaw. That happens usually sometime end of April and early May. Snow depth is critical. Ice freeze up in the fall, ice thickness in the winter, and spring ice out controls the coming and going of large runs of whitefish and salmon, the migrations of moose and caribou. it's important for the moose and caribou to time those freeze ups and thaws, especially in regards to their calving areas, so that everybody, including all the animals, have safe movements on the land. That's very critical. Thank you, Christi. So here's a picture of busy people. The title of the slide, no one has idle hands. We're always learning. Everybody's always busy. Yes, we study. We study reading. We're constantly reading the signs of life and changes around us. For sure, we're studying writing. We keep track of the coming and going of the migration patterns of the geese, swans, cranes, and fish. Math? Every day we use math. How else will we know how much to keep our families fed in the winter, or how to count the squares in a fish net, or measurements on our canoes? In those pictures there, you can see one of our grandmas teaching a younger girl how to make a fish net. And there's some mask dance, our native dancing there is shown in the second slide. And those are swan feathers that are used on the dance fans. And the young lady there with the little puppy, that is a wolf puppy that she caught. That's Santa Hamilton Roach. That's my daughter. And she's also a Globe alumni, which is so cool. But she caught that wolf when she was on a boat ride with her dad when she was in high school. And it was swimming in the river, in the Innoko River. So she caught it. We let it go right away, but it was kind of show and tell day for a little baby timber wolf. The girls on the right there, on the right slide, they're making vankuk, which is it's in English, it's ice cream, Indian ice cream, and it's composed of berries, moose fat, and fish, white fish. That white fish that we were showing you in the fish fence in the previous slide comes from that fish. Picture on the bottom left, there's our grandma Edna, and she's showing kids how to make nets there. She also has some roots for root baskets she has. Picture in the bottom middle is a picture of my husband, Rudy, and my daughter Santa again. And what they're doing right there, that's a swan, that's a spring swan that was caught several years ago. And she was demonstrating how if you blow into the esophagus of the swan, you can make the swan sound. And so all the kids were watching that. And then the bottom right, there's a picture of some beaver tanning that was being done by the students. We're learning from our elder men. So yes, it all matters. And you can see the transformation. Whoopsie. You want to go back to the bunnies? Thank you, Christi. So the transformation right here that takes place was a big question for all of us when we started noticing climate change in our part of Alaska. So you can see that the brown bunny on the left is in that process, and I'm not sure the technical scientific name for it, but when rabbits change from white in the winter, nicely camouflaged, as you can see on the right, and you can tell that green up is going on there with the rabbit on the left. Well, we notice now that since we have been getting earlier thaws, we have been getting green up happening a little earlier. Well, do the rabbits' camouflage coincide with that? Or what's the big picture on that? And the kids were noticing that. So that's been real interesting to study that. Next slide. Thank you, Christi. And it all matters because we are a part of the greater system of life on the planet. All life, from the tiniest unicellular microorganisms to the largest of life that occupies space and time and resources. We are all part of the bigger picture. Yes, it all matters. And that's on the left, that's horsetails. We call it here goosegrass because the goose eat it. Adapting, adopting, creating, conceiving. We look at a bigger picture. We look at the bigger picture, the rounder picture, the cyclical picture, the linear picture, the repeated picture. Adaptations are a huge part of life as our ancestors lead us to today. We keep learning because there are different things to learn and different ways to learn about the things we value most. As caretakers of planet Earth, we adapt to the dynamics around us, and we think and we raise our children to try to understand what we can do better as we share this place we call Earth. And you can see right there, we're using the tools, our students are using the tools of Green Up. As you can see, they have those little, probably a lot of people have those little, in Alaska, have the little panels showing Green Up times. And there we're out on the ice in the fall, ice on our lake where we take ice measurements. And you can see some bud burst happening right there in another slide. The picture in the far right, of course, is green down, which we're able to do green down easier because it happens when school starts. And we're able to get the kids out there and doing that along with, you know, fall fishing, fall hunting, everything that happens in the fall to keep us going through the winter. So thank you, Christi. Next slide. So, you know, and this is how we learn about our lives. We're integrating, we're meshing, we're compiling, we're infusing, we're blending, implanting, instilling, sharing, or incorporating, however you want to put that. We're, you know, the knowledge of our land becomes the focal point for future generations. So, learning the life cycles and things. So next slide, please, Christi. Just wanted to wish happy anniversary to Globe. Those are our traditional masks for one of our dances, native dancing. But we went someplace to a place called Lake Minchumina, and it's right at the foothills of Denali. And we had a big camp there with our school district, and I had wanted to embed I sent it to you, Christi. I don't know if you're able to show it or not, but I sent the video to Christi, and it is this was, I think, done in 2016, maybe. And in 2016, Globe did this, you know, hi, I'm on the Earth right now. Hi, NASA, I'm on the Earth right now. And we just had so much fun there. And then we took this great video of the kids doing some Globe science right in front of Denali there at Lake Minchumina. And so anyway, it was fantastic. And I thank you all for inviting me here to represent the teachers that do Globe in our communities and our tribes. And thank you very much.
Joy, that was so beautiful. And yes, I have the video. I think we can share it after Cheryl's presentation if there's time. If there's questions for Joy, please in the chat, or you can unmute yourself. Thank you so much, Joy.
Thanks a lot, Joy, for this amazing presentation and photos, and thanks for sharing with us the way you live with the community and the way you pass on knowledge and wisdom to young people. Do we have some questions? Actually, yes. Radka is asking. She would like to know what were you doing with that swan on one picture, and how did you get that swan in the first place?
Well, I guess in a way, when people, before cell phones, maybe we'll go there, long before cell phones, you know, with the intimate study that my husband's tribe has going on with all the animals of, you know, that are around in our environment. They found out, and I don't know how, you know, this is something, just some knowledge handed down through the generations, that when you take the windpipe, the esophagus, out of the, when you're gutting the swan and you take the windpipe out, you can blow into it, and the air that comes out of the swan's mouth sounds like the swan. So that's something that kids like to, you know, like to play with. In addition to eating the swan meat and using the swan feathers in traditional dance fans, they have to be swan feathers. So, yeah, so that's why the swan esophagus, making a whistle.
Thank you. Next question, maybe. Radka was asking about the swan, and I'm curious about the wolf. What happened with the wolf puppy?
Oh, the wolf puppy was brought back. My husband and my daughter brought back the wolf puppy after kind of a show and tell period, and the mother did meet up with the pup after that, and all went well as far as we know. You know, the puppy and the mother. I mean, yeah, the puppy and the mother ran off on the river bank and up into the woods after they were reunited.
So I will also have one animal question, and about the rabbits. So you were saying that you observed if their change of fur goes together with a greening up. So what was the conclusion?
So some of the students, when we've been talking about it, and I haven't talked to them about it this year, because right now we are in a you know, the undergoing spring here, and I just saw a rabbit outside my classroom window just a little while ago, right before this, and also an ermine, which is a little weasel, and they're both still pure white. There's no little brown. What we notice is that they start browning like right around their forehead. And but as far as timing, you know, we noticed this in the leaves, and I know Dr. Elena Sparrow, I've been working with her for many years, and a lot of the times we get out of school early, sometime early, usually second or third week in May, first or second week in May. And sometimes green ups is not happening. We don't even have bud burst some Mays. But the earliest that I've seen our bud burst happen was around April 26th. So, you know, when we talk about timing, that can mean a lot of things, you know, and as Christi pointed out, just the weather patterns, the sun, the sun. So, you know, if we were going to really investigate this with the camouflage patterns on rabbits and weasels, it would be interesting to see, you know, how their camouflage, if it coincides, if it happens automatically, if it's pretty well set in their bodily clocks, you know, when that kind of thing happens. And yeah, we would worry though if they're still white while it's brown out, you know, while things have gotten browner. So thank you for the questions.
Thank you so much.
Yeah,
Thank
that's
you.
excellent. And we call that, I think, a phenological mismatch, when the timing is off a little bit. So the species hasn't adapted to these rapid changes that are happening now. So a white rabbit on brown leaves or green grass could be more easily seen by prey. So it would be a phenomenal phenological investigation or inquiry. So Cheryl is laughing at my attempt of a pun, and she is next up for Green Up in Phenology using Globe. Okay, you'll have to unmute there, Cheryl. Cheryl is also a wildland firefighter, EMT, emergency medical technician. Is that right, Cheryl? And trainer. So that's why she's joining from the car.
Thank you. Very honored to be here. Looking at all the many people from many places. I never would have guessed that when I started doing Green Up and Green Down that, you know, this many years later, I would be involved in an international group talking about what I did, because I don't know, I'm kind of here as the logistics person of how do you actually do this in your classroom, especially if you have a traditional classroom that might have, you know, upwards of 35 high school students coming, you know, every hour moving through. So how do you logistically get them out to do phenology and Green Up and Green Down? So you can go ahead and move to the next slide. When I started as a brand new teacher, and I had a class of, you know, 35 9th and 10th graders, I just knew I wanted to get them outside, that we couldn't stay cooped up in the classroom all the time. And so I had gone to Globe training and decided that this phenology thing with Green Up and Green Down would be something that we could do. I worked to find some curricular connections to how do you work it into a biology class. The kids got to learn about NASA and collect their own data, enter the data to the website, and then that can lead to other opportunities with the science fairs and learning expeditions and other activities that Globe does. So it is all kind of worked out, although I never would have imagined that it would have taken this pathway. Okay. So when I start, and just like Joy was saying, we have a little more time in the fall for Green Down. So I do Green Down first, but I would start with just explaining to the students what Globe is. And so some of these videos, like I just said, go through just overall what Globe is, how it's international, and how there's opportunities for events outside of just the classroom for students that are interested. For as far as doing it in a biology class, we also do our ecology usually in the fall. And so it was pretty easy to work that in with the biomes and photosynthesis, energy and ecosystems, and to kind of integrate the phenology with those topics, as well as the technology and talking about satellites and ground truthing as far as how the satellites collect data, but then we need people on the ground to double check it. And the kids always get kind of excited when you can tell them that they're working for NASA. They're not getting paid, but they're working for NASA. Okay. So logistically, so I was lucky enough at both the schools that I worked at that they had some cross-country running trails and some pretty natural forest that the trails went through. But I would advise whatever property area that you have available to you, kind of mapping it out. And when you have large groups of students, I put them in groups and then I assigned them to specific areas. So for us, it was different places along the cross-country trails, but you could use whatever you have available. This gave them some accountability. So they were supposed to be in their area doing their thing, and I could walk around and check on them. Just kind of helps as far as sending a bunch of teenagers outside, somewhat unsupervised. I would define the sites ahead of time and then use them year after year. So certain areas along the trail were marked as site 1, site 2, site 3. So then the next year students could go, they wouldn't choose the same tree, but they'd be in the same general area. And that made entering the data on the Globe website a little easier. They didn't have to define a new site every time. I also decided instead of, at first I told them just choose any tree. And then we ended up with a mismatch of a whole lot of different species, which made it harder to compare because not all tree species will green up or green down at the same time. So I started telling them it needed to be birch. That way we could control our variables a little bit better. Each group had their own branch for Green Up and Green Down. The first time that they go out, I would give them, and you'll see in a second, kind of a checklist of what they needed to do. We would talk about it before we went out, how it needs to be a birch tree, how to determine what a birch tree is and pick one. It needed to be a branch that they could reach without climbing the tree. It needed to be south facing, how to put their flagging tape on, all of that procedural stuff that needs to happen for them to collect data. I also found that because weather is unpredictable and they'd be going outside multiple times to check, using Write in the Rain paper and just copying the data sheets onto that made it so we had less of the data that would disappear once it rained, and also giving them the fancy clipboards so they could keep everything in one spot. With multiple classes, I would have, say, 3 or 4 classes of biology. So there might be 3 or 4 branches that are all at what I called Site 1. And so Site 1 had one clipboard and everybody's data sheets was in there. And that way, each hour that clipboard would go out, it would go to that site and that group would record their data on their data sheet. And it's always good to check those data sheets. Almost every time they would go out, as they came back in, I would look at their data sheet and be like, oh, you forgot the date, or oh, you only wrote down 1 leaf, or make sure that they've filled it out completely. And I guess the other thing was just prior to having them go out like this and actually collect data, I did some activities because some of them had never been out on the cross-country trails. So telling them to go to this corner on this map was kind of hard. So we did a photo scavenger hunt that just got them out there walking the trails, looking for different items and getting familiar, so that then when I assigned them to their actual data site, hopefully it was easier for them to find. Okay. Okay, so after doing Green Up for a few years, what do I remember as being kind of the trouble spots and my advice kind of hints for for it to be more successful? Again, telling them to use, if not the exact same tree or branch that they had for Green Down, that would be ideal, but sometimes the flagging tape falls off or the tree gets eaten by a moose or something like that. So just find another south-facing branch on a birch tree and have that be their Green Up branch that they're checking. I would bring in, and this was my attempt at doing that. If you go out and just cut, say, a birch branch and put it in water, and bring it inside where it's warmer, then it will go through the process of swelling and bud burst in the classroom. And I could take pictures of that and they could kind of see it happening before it actually happened outside. And that would give them an idea what to expect and how to identify dormant swelling bud bursts. That never seemed to be much of a problem. That was pretty easy. And then the challenging part, though, was once the baby leaves pop out, because 2 things: they have to know centimeters are different than millimeters and do that consistently. So that was something I had to check on their data sheet, is they would switch from millimeters to centimeters and it makes it look like their leaf got smaller. So I'd have to kind of correct that. And then also, usually when that bud opens up, there's not just 1 leaf. There might be 4 or 5 leaves that all pop out. And so which leaf do I measure? And especially if you have 4 buds, then each of those buds could open up with 4 or 5 leaves. And so I'm not sure if there's a protocol for this with Globe, but I would just tell them, pick the average one. And you probably might not do, that's consistently, doing it consistently is a trick, because you measure 1 leaf one time you go out, but unless you mark it in some way, how are you going to measure it again? So it was just a good conversation about consistency and data. Other things that were harder for Green Up is the season is very, very short. It usually happens very quickly in Alaska, and it's also at the very end of the school year. So we didn't always get to continue checking very far into making the measurements. We usually did have swelling and bud burst happen before school got out. And also, spring conditions are just messy, and high school kids don't always like to get their shoes dirty, or it's cold, or it's wet, or it's slippery. So actually, compared to the fall, doing Green Up required them to be a little more prepared. And then the thing that I wish I had done more consistently and written it down, because you end up with all these data sheets with all of this data, but like what Christi showed with that video, it's usually pretty obvious when Green Up happens. You go from looking at your trees in your forest and it looks more brown or red to green. And that's a day or a couple of days. And if I had written down those dates every year for 25 years, then that would be a really interesting thing to look at. Now, yes, we can still go back to the data and kind of figure it out, but I just wish I had jotted that down along the way. Okay. All right, so this is kind of what it would look like. What I would send them outside with is they would have a list of things that they need to do. There'd be pictures. Of course, in the spring, this worked for green down, showing the leaves, the shape of the leaves so that they could use that to identify the tree. Doesn't work so good in the spring when there really aren't any leaves. So I'd need to do something different for green up. As far as that information goes, but it gives them some accountability on what they're supposed to be doing. And then the data sheet is also in there. I would copy it with the top part already filled out. And that way, you know, I would write on there which study site they're at and which class period it is, so that hopefully they could put their data in the right place. Next. I just want to share this as one of the activities that I always did with Green Up and Green Down. It's more of a traditional classroom activity with, it looks just like a worksheet, but I found the kids kind of got into it and they would do it, and it helped them think about Green Up and Green Down on a global level. It basically, and also goes really, really well if you teach biomes. So there's the 5 different biomes and the 5 different graphs, and they're basically challenged with figuring out which line on the graph matches which biome. And then looking at the data and filling out the kind of worksheet there with highs and lows, and how did you know? How did you know that this one was tundra? How did you know that this one was a desert? And yeah, I just felt like it was a good kind of follow-up activity. And okay, so another kind of tandem activity you could do is that the land cover, as far as determining their dominant species and determining canopy cover, and just getting them to walk through the actual natural forest and look up and look down. There is an app that you can do this very simply with, but I also kind of like the old school method of making them walk a transect and look up and look down, and then calculate their percent evergreen, their percent deciduous. There's a lot of good vocabulary in this lesson that goes along with your biome study. So I would have them do this method first before I showed them the app. And then I would let those that, and things are changing in schools. It used to be try to find ways to use your phones at school. And now that's kind of changing to lock them in a bag and you don't get them out all day. So this was during the phase when I was trying to get them to use their phones for education. And so I would encourage them to use the app while we were outside to collect data. That might be a little bit more challenging now that phones are kind of being banned from the classroom. Next. And then this is what I already said, that you can repeat that same activity and do it with the Observer app. That's what I've got. Hopefully it's helpful.
Thanks a lot, Cheryl. I believe this was very inspiring for all the teachers who are with us today. Thanks for sharing with us this good practice of how to long-term phenology with students. And time for questions.
I don't have a question, but I just want to say thank you so much for sharing these experiences. Also, the troubles that you encountered with doing the phenology observation, because we often do have these problems, like teacher write us about how to choose the one leaf if there are more leaves from one bud, and some of these questions. So it's really helpful to hear from your experience and to share it. Thanks a lot for that.
I have one
No
question.
problem.
Thank you very much, first of all. And you know, it's very interesting that you're so actively involved in all this process, and you work with the students at the school time or like an extra activities after school, or how do you have so much time to do so active activities in the globe? Because when I work with my students, I always do it after the all lessons, after school time, like an extra informal part of education. Thank you.
Yeah, it is. It is challenging for sure, and it is much easier to do a small group after school. And I had to, I guess, prioritize because I could get lost in doing globe activities for weeks and weeks and not cover everything else, And so I had to say, okay, we need to talk about biomes, but biomes is usually just like a 1 or 2 day lesson. And if I do all of these activities, it's going to take a week, but they're such good activities. And so, yes, it's definitely challenging.
Yes, great. Especially as I guess you can do it, especially as an ordinary lesson, yes, in school time.
Yes.
Yeah, great. Thank you.
That's really definitely very, very true, Cheryl. There's just so much in Globe, and you want to teach it all. And this was great. I really had fun listening to you. Good to see you again too, Cheryl.
Okay. We have 1 minute or so for the last question, maybe. We kind of over time, so the last question, if anyone would like to ask any of our speakers today.
Yes, Cheryl, sorry for interrupting. I also say only one small comment, okay?
Sure.
Yes. Really, it's very, for me, it's really first time that I can see the working in so far in our farthest region is Alaska, yes. And then especially in nowadays that some students can do such activities like in ancient indigenous population like Indians, tribes and so on. It really was very amazing because for our students, yes, to see this one and to use some the feathers and law, it's very strange for us because they can see only chicken frozen in the market, yes, and they can do their own and also knit the fishing nets on your own. It's really very great opportunity, and I'm very, very glad to see all this on my own. Thank you.
Yes. Thank you so much for the practical examples and making it so personal for us, because I believe that many of us, we don't know so much about your culture. So it was very inspiring, not only the phenology part, but all the cultural and community aspects. Thanks for sharing with us. Beautiful. Okay, so as time is up, I would like to thank you again for all your presentations. Hope that you will join us another time. And for all the participants, we will share the presentations and this recording with you. You will get it via email. And one last thing before we close for today, I would like to invite all of you for the final webinar of the Spring Phenology campaign, which will be on the 2nd of June at 3 p.m. CEST time. And this will be a sharing webinar. So it will be a great opportunity for all of you who are doing phenology observations this spring to share it with us, with everyone, and to inspire each other. So save the date. You will receive all the information about this webinar and the registration link when the time comes closer. So wish you a wonderful rest of the spring, almost summer here in the Czech Republic. And thanks for joining today, and good luck with the Phenology campaign observations. Keep up the good work.
Well, thank you so much for inviting us today. It was such an honor and really fun. And I'm blown away by how many teachers took time in your evenings to come, and scientists who came, who you're leading an amazing European phenology campaign. And I can't wait to start comparing data from you and here in Alaska. I think that'll be really fun.